In this problem, we're asked to find the angle between two planar surfaces, A and B. So this is also called a dihedral angle. And we're given the front and the right side view. So here's the front, and here's the right side view. So we know right off the bat that the fold angle, or the fold line, between these two views is going to be a vertical line. So this would be a fold line between these two. The fold line can also be thought of as a plane of projection. And I can see that if I want to find the angle between surfaces A and B, I'm going to need to look at the point view of edge 1, 2. So this edge or this edge. And if I look at how that edge is oriented to the fold line, I see that it's not parallel to the fold line. And therefore, the edge is not going to be shown true length in either of these two views. But I can create a view where it's shown true length by adding a fold line that's parallel to edge 1, 2 in one of these views. So what I've done here is I've put this fold line here parallel to edge 1, 2 in the right side view. And this fold line I've just moved over. That could be, the fold line can be located anywhere. Its angle is what is important, but not where it is, left or right in this case. And once I create that fold line, I'm going to draw projectors that go from the corners of the view. So each of these numbered corners, 1, 2, 3, and 4, and the projectors have to go perpendicular to the fold line, or perpendicular to the projection plane, in other words. Now what I want to do is measure the distances from the previous fold line to the points. So I want to measure these distances, and then transfer these distances from the new fold line, from this angled fold line, up, so that I can locate the points. So what you see is that I've measured these distances. So from the fold line to point 1 was 1.2, and I'm measuring in centimeters. So in other words, I go from this fold line up to point 1, and that distance is also 1.2. So that's how I located this point 1. And I know this is point 1 because I'm going from point 1 in this view. And so for point 2, I go from point 2 in this view. That's the projector I'm using. And I know that point 2 is on the fold line, so the distance is 0. And so point 2 ends up here. And then I would do the same thing with point 3. That distance was 1, so that's how I got this. And then for point 4, that distance was 2, so this distance is 2. That's how I got point 4. I then connect the points the same way that they're connected in the other views. So for example, point 1 to point 2. And when I connect all of the points, I get lines. So I see how my planes have now been, my planar faces have been reoriented. More importantly is that this line 1, 2 is now a true length line, or a true length edge. So now that I have a true length line, I can find the point view of that line by looking straight down the line. So what I do is I add another fold line, this time perpendicular to that true length line, because now I'm going to look perpendicular to the true length line in order to get the point view of that line or that edge. So this is the fold line, the new fold line. And just like before, I draw my projectors from the points perpendicular to the fold line, and then I plot the points by measuring the distances from the previous fold line back to the view. So in other words, for example, for point 1, I know that point 1 is going to be along this line because it originates at point 1. And so I take the distance from this fold line back to point 1. And whatever that distance is, I've transferred it here. Okay, so I plot points 1 and 2, and those end up being on the same point, because the distance from the fold line to point 2 is the same as the distance from the fold line to point 1. And I do the same thing to find point 3 and point 4. And then once I do that, I connect the points the same way that they're connected in the other views. So point 4 gets connected to point 1 and point 2, but those are in the same location. And point 3 gets connected to point 1 and point 2, but again in the same location. Those are in the same location. So if I zoom in here, I can now see that I've got a point view of this edge 1, 2. All it shows up as is a point. And I can measure the angle between the points, or between the lines, I should say. So this edge and this edge, the angle between them is 10 degrees, and that's the angle between planar surfaces A and B. So just to recap, in solving this problem, I needed to create two auxiliary views. So the first one was called the primary auxiliary view, and the second one was called the secondary auxiliary view. And the reason that I had to do that is I knew I wanted the angle between the two planar surfaces. And in order to find that angle, I needed a point view of the edge, basically the fold edge. We could imagine if surfaces A and B, if that was a piece of paper and I folded it to create edge 1, 2, then I wanted to look straight down that edge in order to find the angle between surfaces A and B. So in order to get that point view, I first needed to see the true length view of edge 1, 2. So I first, in the primary auxiliary view, I first had to get the true length of edge 1, 2. And then in that secondary auxiliary view, I got the point view of 1, 2. And then from that point view, I was able to measure the angle between the two surfaces.